request, you have noted the three sequence component, that is positive, negative, and zero sequence. Why do we require all this sequence component? Because we know that if there is an unsymmetrical fault in our system, then the inrush current in the various phases, the three phases of our power system will not be same, because we know in case of the symmetrical fault or the balanced fault, if we can calculate the value in one phase, the same will be there in the other two phases. But this is not the case with the unsymmetrical faults, right? What happens in the unsymmetrical fault is different inrush currents will flow to the different phases. Like if we note here the phases by A, B, C, let us write the nomenclature of the phases as A, B, C. Generally, we note the phases by R, Y, B, right? So, in case of our nomenclature, this A will stands for R, this B will stands for Y, and this C will stand for B. So, the general phase sequence is ABC, wherein we can say that these three phases are separated with each other by an angle of 120 degree. That means if I want to draw the phasor, then I can draw the phasor in this way. So this is the balanced phasor. So if this is A, this is B, and this is C, all these three phases are separated with each other by an angle of 120 degree each. So if I say that the phases are different, phases are associated with each other by 120 degree, then this is the original phasor. If I change this phasor, let's say if I change this original phasor to ACB, then what will happen? Then the position of this B will be taken by C and this C will be taken by B. Whereas the A will be as it is because we are taking A as reference. What we did here, we have taken A as reference phasor. Okay. So in this way, what we can do is we can change this particular phase. What is the significance of this is that whenever we deal with the three-phase network, you all know where these three-phase networks are used. Three-phase are basically the HT consumer. Who are these HT consumer? HT consumers are the high tension consumers who require the 440 volt supply. So this 440 volt supply is basically a three-phase supply, right? And who are the LT consumer? LT consumer means low tension consumer, who are the normal household who require the 220 volt or 240 volt supply, right? So this will be necessarily the single phase supply. So when we deal with this single phase and three phase supply, this three phase supply will be mostly used by industry, right? And this single phase supply will be mostly used by the commercial household users. So when we take the case of the commercial household users, when the power supply comes, you all know that there will be a electric pole in front of your house, right? This will be the electric pole in front of your house, and there will be various connections coming from the distribution board, DB. We say that DB, right? So there will be a distribution transformer, and with the help of this distribution transformer, there will be a supply coming to this pole. Then from this pole, there will be various households where this power supply will be going, right? So this power supply which is going to these various households, these are of 220 or 240 volt single phase supply. But when this distribution comes from the distribution transformer, this is a 440 volt supply. So this 440 volt is then distributed to the various households by using a 220 volt supply, or in other words, we can say that this three phase is converted into, here these three phases are ABC. Now when this will go to the consumer, some consumer will get A phase, some consumer will get B phase, or some consumer will get C phase. So here you can see that this entire power of three phase is converted into single phase. So whenever there will be failure in this particular end, whenever I say that if there is a failure at this end or a fault has occurred at this end, what will happen? This fault, because of this fault, there will be an unbalance in the system, and this unbalance can penetrate into the system of the household users, let's say in phase A or in phase B or in phase C. So whatever phase it will go, the user has to get protection at their level so that their equipments will get protected and there will be no damages to that particular household. At the same time, the discom companies, the distribution companies who are distributing this power, they also have to install the necessary protection devices that you can see here. This type of protection devices are installed here so that this inrush current is limited by the current limiting reactors and the various other protection devices which you will be learning in switchgear and protection subject of your 8th semester. So in this way, we have to understand what is the role of this three-phase system into our system. And when we talk about this three-phase system, in unit 1 and unit 2, whatever you have learned, you have to convert this into the three-phase system. So if we want to convert this into the three-phase system, then we have to make the necessary arrangements which will be related to this three-phase system, like formation of Z bus in the three-phase system, because in the 5th unit we will be dealing with the symmetrical and the unsymmetrical faults. So this symmetrical and unsymmetrical faults will be then deal with the bus numbers, as you have found out the Z bus in unit 2. So the Z bus that we have formed in unit 2 was a n by n matrix, right? See, I'm writing here, all these things can be asked in the MCQ based questionnaire. So you have to be prepared. What is n by n or what is n? N is the number of buses, right? What is n? N is the number of buses. That means if we say that we have 4 buses in our system, then what will be the size of this matrix? The size of this matrix will be 4 by 4. If we say that our system is having 100 buses, then what will be the size of this Z bus matrix? The size of this Z bus matrix will be 100 by 100. But it's not possible for us to make a 100 by 100 matrix in our by using pen and paper, right? So for this we have various computer simulation softwares which we will be seeing in the practical part of the computer application in power system. So with the help of those programs, those codes, then we give the various inputs to this program, and with the help of these inputs, what we do, with the help of all these inputs, we frame this Z bus first. After getting the value of this Z bus, then only we will be in a position to apply the various formulas which are related to the calculation of the fault current, all the voltages in the faulty buses or voltages in the healthy buses. So all these formulas will be applied and then we can find out the answers. What is the outcome of doing all these things? We should understand. Outcome of doing all these things is we have to design the necessary protection devices which you are learning in the switchgear and protection. So you are learning various types of relays, current limiting reactors and other necessary accessories which are required in the power system in order to protect the power system from various types of faults or from various types of unbalances which are happening into the power system. So for this we require mathematical calculations, right? And for this mathematical calculations we should know what is happening in each and every buses. So in the previous slide, like we seen that the 3 phases are A, B, C, and these 3 phases are separated with each other by 120 degree each, right? So if I take these 3 phases and analyze, you all know that there are sequence components also. You have learned this in EPS 2. What are the sequence components? The sequence components I will write here one by one. This is the 0 sequence. 1 is represented by the positive sequence and 2 is represented by the negative sequence. So we have this 3 sequence components available with us which actually helps us to convert the unbalanced or the unsymmetrical power system into a symmetrical one. Because if we convert this unsymmetrical into a symmetrical one, it becomes easy for us to do the calculations, right? So whatever bus that we will be forming, this bus will take the shape like this: 0, 1, 2, and then we will make the Z bus. Okay, so 0 will be representing for zero sequence, 1 will be representing for positive sequence, and 2 will be representing for negative sequence. Why do we require this? Let us understand first. If you all remember, in EPS 2, we have said that in a symmetrical fault, only positive sequence is present. Do you all remember this? कितने लोगों को ये चीज याद है कि सिमेट्रिकल फॉल्ट मतलब थ्री फेज फॉल्ट, राइट? सिमेट्रिकल फॉल्ट में सिर्फ पॉजिटिव सीक्वेंस कंपोनेंट ही प्रेजेंट रहता है. हाउ मेनी ऑफ यू रिमेंबर, स्टिल रिमेंबर दिस? 7th सेम का एग्जाम तो दे दिया सब लोगों ने. कितने लोगों को ये चीज पता है कि सिमेट्रिकल फॉल्ट में सिर्फ पॉजिटिव सीक्वेंस अवेलेबल होता है, जीरो और नेगेटिव सीक्वेंस नहीं रहता है, राइट? सो यहाँ से फिर हम जब पॉजिटिव सीक्वेंस लेंगे तो हमें Z बस 1 लेना पड़ेगा. Z बस 1 का जो वैल्यू है वो हमें लेना पड़ेगा फॉल्ट कैलकुलेशन के लिए. किसके लिए लेना पड़ेगा हमें ये चीज हमें लेना पड़ेगा फॉल्ट कैलकुलेशंस को फाइंड आउट करने के लिए हमें पॉजिटिव सीक्वेंस का Z बस चाहिए. अब ये पॉजिटिव सीक्वेंस का Z बस कैसे दिखेगा? लेट अस से फॉर एग्जांपल इफ आई हैव ए 3 बस सिस्टम. ठीक है, टुडे वी आर अंडरस्टैंडिंग द बेसिक्स ऑफ दिस यूनिट 3, क्योंकि कल से फिर जब फुल फ्लैश स्टार्ट कर देंगे तब हमें डिफिकल्टीज नहीं चाहिए, है ना? तो आप लोग यहाँ अच्छे से समझ लो. सपोज आई हैव ए 3 बस सिस्टम. मेरे पास एक 3 बस सिस्टम है. तो 3 बस सिस्टम जो है, 3 बस का Z बस मुझे कैसे मिलेगा? लेट मी राइट हियर. 3 बस का Z बस मुझे कुछ इस तरीके से मिलेगा: Z11, Z12, Z13, then Z21, Z22, Z23, then Z31, Z32, Z33. ये 3x3 मैट्रिक्स है, क्योंकि n बस सिस्टम है तो n/n मैट्रिक्स होता है, तो 3x3 मैट्रिक्स बना. बट आई हैव नॉट कंसिडर्ड द इफेक्ट ऑफ द सीक्वेंस कंपोनेंट. अगर मुझे इसे पॉजिटिव सीक्वेंस के लिए लिखना है, पॉजिटिव सीक्वेंस के लिए अगर मुझे लिखना है तो यहाँ मुझे देना पड़ेगा 1. और ये सारे वैल्यूज कैसे हो जाएंगे? इस तरीके से हो जाएंगे ये सारे वैल्यूज. अच्छे से देखो मैं क्या कर रहा हूँ यहाँ पे. बाद में फिर पूछना नहीं कि ये कैसे आया और वो कैसे आया. इन सबके ऊपर मैंने क्या कर दिया? Z11 1, Z12 1, Z13 1, Z21 1, Z22 1, Z23 1, Z31 1, Z32 1 और Z33 1. ये क्या हो गया? ये हो गया पॉजिटिव सीक्वेंस का Z बस. किसका Z बस हो गया ये? रिप्लाई करो चैट बॉक्स पे. किसका Z बस हो गया ये Z बस हो गया पॉजिटिव सीक्वेंस का. किसका? पॉजिटिव सीक्वेंस का Z बस. मतलब अगर मुझे ये सिमेट्रिकल फॉल्ट कैलकुलेट करना है तो मुझे Z बस 1 की रिक्वायरमेंट होगी. किसकी रिक्वायरमेंट होगी मुझे अगर सिमेट्रिकल फॉल्ट कैलकुलेट करना है? तो पॉजिटिव सीक्वेंस कंपोनेंट. सिमिलरली अगर मैं बोलूं मुझे लाइन टू ग्राउंड फॉल्ट करंट निकालना है, तो आप सभी को याद होगा लाइन टू ग्राउंड में हमारे तीनों सीक्वेंस अवेलेबल होते थे. जीरो सीक्वेंस भी होता था, पॉजिटिव भी होता था, निगेटिव भी होता था, राइट? तो उसके लिए मुझे फिर Z बस 0 लगेगा, क्योंकि Z बस 1 और 2 सेम रहता है, तो Z बस 0 लगेगा. अब Z बस 0 की वैल्यूज कैसे होगी? Z11 0, Z12 0, Z13 0, Z21 0, Z22 0, Z23 0 और सिमिलरली Z31 0, Z32 0 और Z33 0. ओके, तो ये हो गया मेरा Z बस 0 का Z बस. ओके, दैट मीन्स डिपेंड करेगा कि कौन से फॉल्ट का हमें कैलकुलेशन करना है, उसके हिसाब से हमें Z बस चाहिए रहेगा. तो इस यूनिट में हम क्या करने जा रहे हैं? इस यूनिट में हम ये Z बस 0 1 2 को कैलकुलेट करने जा रहे हैं. Z बस 0 1 2 में से Z बस 0 will be sequence will be different whereas Z bus 1 and Z bus 2 this will be same. ठीक है, दैट मीन्स हमें ये दो Z बस अलग अलग निकालने हैं, तो हमारा ये यूनिट 3 कंप्लीट होगा। 3, तो फर्स्ट टॉपिक हम ले रहे हैं यूनिट नंबर 3 का। फर्स्ट टॉपिक के लिए आप लोग कॉपी में लिखेंगे इसको, 3 फेज नेटवर्क इन इम्पिडेंस फॉर्म। Okay, so how to write the three phase network in terms of the impedance form? ठीक है, so I will draw the diagram here, so you also have to draw the diagram here. So I am going to draw the diagram here, so you can also draw the diagram, and according to this diagram we will represent the three phase network in impedance form. So what we are writing here is now in the form of impedance. So I hope you all are familiar with this terminology PQ, right? So I hope every one of you are quite familiar with this terminology PQ. We have solved many numericals related to this PQ in the unit number 2. Okay, so in this way we are going to represent the impedance form of reference. Let us see how to write the equation of this impedance form of reference of three phase network. So this is the associated diagram with it. Maybe kabhi kabhi three phase network is represented diagrammatically in terms of the impedance form. Now we will write the mathematical form. हम देखेंगे कि mathematical form में impedance form को किस तरीके से लिखा जाता है. So in the form of matrix, let us write this. So in the form of matrix, we will write in this way. V P Q A, V P Q B, and V P Q C plus E P Q A, E P Q B, E P Q C is equal to Z P Q A A, Z P Q A B, Z P Q A C, then Z P Q B A, Z P Q B B, Z P Q B C, Z P Q C A, Z P Q C B, Z P Q C C. And here we will have I PQA, IPQB, and IPQC. Let us give this equation number as equation number 1. Okay. So this equation number 1 is known as the impedance form of three-phase network. Is that clear, everyone? What is this uh, equation number 1 called? We will write all these components. What is the name that we have written? What is this VPQA, VPQB, VPQC? We will write here one by one once you all are completed writing this. So हो गया सभी का लिख के PQA, EPQB, EPQC. Let us write what is this? These are the source voltages. Okay. What are this? These are the source voltages in series with phase A, B, C respectively of elements P डैश Q. बराबर. P और Q हमने लिखा है हर बार नीचे. तो एलिमेंट्स जो है हमारे एलिमेंट स्टार्ट कहाँ से हो रहा है? P से, और एंड कहाँ पे हो रहा है? Q पे. राइट, क्योंकि यही नोमेनक्लेचर हमने यूनिट 2 में लिखा हुआ है. Similarly, we will write here what is VPQA, VPQB, and VPQC. So what is VPQA? Let us write here VPQA, VPQB, and C. These are nothing but the potential differences. We have to remember all these nomenclatures. It may be asked in the MCQ type questions. So you have to note all these things across elements P and Q for A, B, C phases. Okay. As we are writing for these phases, we have to write these phases also. Then what is IPQA, IPQB, IPQC? So these are the currents, as the name itself is denoting I. So currents through the elements. What are the elements? P dash Q for A, B, C phases. Right? So these are the currents which we are using for the phases A, B, and C. Then let us see here what is Z. We have in the center written a block, that is Z, P, Q, A, B, C. Right? So what is this? Let us write this. This is three-phase impedance matrix, which you have written in the right side. Three-phase impedance matrix. Right? And then what we have written next is Z, P, Q, A, A. So Z, P, Q, A, A, Z, P, Q, B, B, and Z, P, Q, C, C. These are the self-impedances of phase A, B, C respectively between nodes P and Q. Right? And similarly, we have the off diagonal elements, right? What are the off diagonal elements? Off diagonal elements, you all know, ZPQAB will be equal to ZPQBA, right? Similarly, AC will be equal to ZPQCA, and similarly ZPQBC will be equal to ZPQCB. And what are all these elements? These are the off diagonal elements. Off diagonal elements, and these are nothing but the mutual impedances of A, B and C respectively between nodes P and Q. Okay, so this is all that we have written with respect to this equation which we have written just now. थोड़ी देर पहले हमने जो ये इक्वेशन लिखा हुआ है, इस इक्वेशन के हिसाब से हमने ये सारे पॉइंट्स अभी लिखे हुए हैं. ओके, ये सारे जो पॉइंट्स हमने अभी लिखे हैं वो किस हिसाब से हमने लिखे हैं? ये सारे पॉइंट्स हमने अभी जो डायग्राम हमने निकाला हुआ था अभी थोड़ी देर पहले. लेट अस सी द डायग्राम वंस अगेन. So this is the diagram which we have drawn. So which is nothing but the three-phase network in impedance form. Okay. So this is what is known as the three-phase network in impedance form, and this equation 1 is called the performance equation of a three-phase element in which form is it? This is impedance form, so that's why I will write here in impedance form. Okay, so this is what we have in today's lecture. So I will summarize whatever things we have learned in today's lecture. In today's lecture, we have learned about the three-phase network in impedance form. So three-phase network in impedance form looks like as it is shown in this picture, where we have the various terminologies according to this equation. EPQA, EPQB, EPQC, these are the source voltages in series with phase A, B, C respectively of element P and Q. VPQA, VPQB, VPQC, these are the potential differences across elements PQ for ABC phases. IPQA, IPQB, IPQC, these are the currents through the elements PQ for ABC phases. ZPQ-ABC is three-phase impedance matrix. ZPQ-AA, ZPQ-BB, ZPQ-CC. These are the self-impedances of phases A, B, C respectively between nodes PQ. And finally, ZPQ-AB is equal to BA. This we all know. ZPQ-AC is equal to ZPQ-CA. And ZPQBC is equal to ZPQCB. These are nothing but the off diagonal elements which are the mutual impedances between A, B and C respectively between the nodes P and Q. Alright,